So our question was number 3. State whether the graph represents a function that is even, odd, or neither. Explain your reasoning.
The function is neither even or odd because the graph does not reflect across the y-axis.
Alright, my name is Daniel. My name is Roberto. And we got question number 3, which is state whether the graph represents a function that is even, odd, or neither. Explain your reasoning.
Alright, what we got is the function is neither even or odd because the graph is not symmetric, as we can see right here, about the origin, and it's not symmetric about the y-axis, as we can see right here.
Describe the end behaviors. We have our both functions, and the first one is r of x equals 7x to the power of 9 plus 3x to the power of 4 minus 4x plus 8, and the other function is h of x equals negative x to the power of 12 plus 2x to the power of 7 plus 9 to the plus 9x to the power of 2 minus 4.
So for each equation, what we did was figure out the first exponent of the function. So for r of x, it's 9. So 9 is odd. So the graph would be an odd graph, obviously. So obviously we don't know what it would actually look like, but it's odd. So either way, it's gonna be going opposite directions for the arrows, and since the a value is a positive, it would be going up. So then that would make it as x goes to infinity, positive infinity, f of x also goes to infinity because as you go to the right, it's going up. As x goes to negative infinity, f of x goes to negative infinity as well, because as you go to the left, it goes down. Okay, and for the next one, for h of x, the a value is negative 1, since there's no number right there, you just be negative 1. And the first exponent is 12. And that's even, so it will look like a frowning face, obviously. And since it's a negative, it would be going down. Both arrows would be going down. So as x goes to positive infinity, f of x goes to negative infinity. Because as it's going to the right, it goes down, and as x goes to negative infinity, f of x also goes to negative infinity, because as it goes to the left, it goes down. And yeah, that is question number 5. Describe the end behaviors of each function.
Because p of x is x minus 3, you have to subtract 3 from x. So the new points are negative 3, 0, negative 2, 1, and negative 1, 8. And this is the new line on the graph.
The points of p of x are 0, 0, 1, 1, and 2, 8.
So for letter B, we have x to the 6th power, or a 6-degree polynomial, and we just insert it to the degree, which is here, and we take 6 and subtract it by 1, which we would then get 5. Go.
Our question is sketch the basic shape of each function on the set of axes given the number of zeros of the function. 10a.
So 10a says quartic polynomial with exactly 3 zeros. So the zeros mean the 3 zeros are on the x-axis, and then we have to make it a quartic polynomial, which is x to the 4th power. So there has to be 3 extremas to know that it's a 4th polynomial function. Thank you.
Elio, and my partner is Nathan. For our problem, we got a quintic polynomial with exactly 4 zeros.
We had to sketch it out, and we ended up getting this as our sketch.
we know that there are 4 zeros, which we plotted right here. And we also know that there are 4 extremas, which as you can see right here.
Okay, hi, I'm person 1 and I'll be explaining the table. So when you add all of these together, you realize that you add by 3 each time, which since it has the first common difference, it means it's linear, which that is x to the first power.
And I'll be explaining this equation. And since it's a subtraction with the multiplication, you have to add the polynomials, which gets you x to the 5th. And the equation is degree minus 1 equals the 5th from the power, so it's 5. Then you add 1 to both sides, which makes you 6 equals degree. And since 6 is greater than 1, this one is the greatest, has the greater degree.
Say it again.